Yaskawa.
Let's look at how to use SigmaWin Plus to set up a torque control application. So here's the application story. We have customers doing positioning as shown in this simplified diagram with a torque control command into the amplifier. It's set up in such a way that the controller is expecting 2.25 volts to command 50% of the motor's torque into the amplifier. And not only that, but in the clockwise direction. The controller is expecting to see 1,000 pre-quad pulses back per revolution of that encoder. And as it says, the controller is also programmed to command speeds below 1700 RPM. And in case that should not happen, we want to be sure that the amplifier limits the speed to 1700 RPM. If that happens, we would like to have the output SO3 indicated here at pins 29 and 30 to turn on, and that's the velocity limit VLT output. One additional application information is that the overtravel sensors of the amplifier will not be used. Instead, the overtravels are going to come in directly to the controller. That does happen from time to time. Here for this training, what we'll do is go through these instructions, initialize the parameters. We'll use a setup wizard and label these terminals, look at the list of change parameters, and verify the operation on the demo. So let me start here in SigmaWin Plus, and I'll go to the parameter screen, and under edit parameters you can initialize to factory default and click OK, and then I'll get out of here. Now it does say that I have to cycle power for the change of parameters, but I'm just going to do that all at once after I go through the setup wizard. So let's go into the setup wizard, and I'll hit encoder connection. I'm not using the fully closed encoder, and we'll start with the control mode. And we know from this setup that we're going to be commanding torque, so I'm going to choose torque control mode and hit apply. Next is the reference setting, and here it says 2.25 volts commands 50% torque, so I just can enter that in here. 2.25 volts commands 50%. Then you hit calculate and apply. Next is the encoder setting. Back here in the application it says that the controller is expecting 1,000 pre-quad pulses per revolution, and this parameter is the number of pre-quad pulses per revolution, not post-quad. So I'll type in 1,000 pre-quad pulses per revolution, and this table here shows that I will have the full motor speed up to 6,000, although I really don't need it in this case. Nothing mentioned about absolute or incremental encoders, but on the next page of this area we notice that there is a standard setting of counterclockwise. We want to have the forward reference instead be clockwise on this application, as given here where it says motor torque in the clockwise direction. Now you've always got to be careful about that because the viewpoint can change your definition of what's clockwise and counterclockwise. Let's just assume we mean looking at the motor clockwise. We want reverse mode. Apply. The motor stop section has to do with stopping at alarms, and I don't see anything mentioned about stopping at alarms. It does mention a speed limit, but that's not part of this area, so we can just skip over it and go here to the I/O setting. And here it says that output SO3 should turn on, and that's the velocity limit output. So let me go to the outputs, and we'll see here is VLT, velocity limit, and we are expecting it to be on SO3 pins 29 and 30. So what I'll have to do is take off the default and put on velocity limit on SO3, and when I click OK, it warns me about this dual allocation. If that is the default, I can just click yes and accept that, and I now see in the graphic that velocity limit is on pins 29 and 30, just as was expected here. Pins 29 and 30 will be velocity limit output feedback back to the controller. And then for inputs it says that overtravel sensors will be connected to the controller, not the amplifier. So I'll go here and remove the pot and nut. Now you also could just not wire them, but if you don't wire them, these are normally closed signals, and you'll have the pot not condition. So it's a good idea to go in here, and I see here I've got pot and not, and I'll set those to off so that over travels are not used on the amplifier. You click OK, and you can see here the graphic is updated as well. That brings me to the end, so I'll hit apply. And don't forget the last step, save, write. I like to first save this file in case I need to come back to it. So I'll hit save, call it torque mode example. And now I'll write with a backup file, meaning write, and save the existing parameter file. Now, that's just the defaults. Can't hurt to save it. I'll just save it with the default and write the result of the wizard into the servo pack. And now I do have to cycle power, so I'll finish this wizard up, cycle power. Okay, and my input status is not updated here, so I'll need to look at reconnecting, file reconnect, and connect again to this servo. Back to my application summary, there's one thing I haven't done here, which was to set the 1700 RPM speed limit. And there was no place to do that through the wizard. I'll just have to do that straight through the parameter editor. So I'll go to parameters, edit parameters. And that speed limit, although you might expect it to be a speed parameter, it's related to torque mode. It's a speed limit for torque modes. I'll go to the torque tab. PN 407 is the speed limit. You can see the default here is 10,000 RPM. Min minus 1 means RPM in this software. And we're not implying that the motor can go 10,000, but we're just putting the limit out of the way. I'm going to change that then to my required 1700 RPM. And we can write that one in. That's an immediate parameter. I don't have to cycle power. And I'm done with the parameters. Now to test this parameter set on the demo, this is the demo we use here at Yaskawa Training. Got all the inputs and outputs wired and a little motor with a wheel on it. I'll first use the wiring check. It's a good way to confirm that your command voltage is correct. So under monitor, wiring check, I'll turn up the torque to 2.25 volts and just confirm that that does produce 50%. So there it is, 2.25 volts, 50%, and this is a positive voltage, and you just have to trust me here. I can see the motor is moving counterclockwise. So that takes care of the first two. The second one, use the motion monitor to confirm the speed is limited to 1700. And so to look at that, I'll just move this window over. 1700 is the current motor speed. And I can also see at this point that the velocity limit has been reached. It says here low, meaning that it is active. You can see right now the torque is 3. If I put my hand on the motor, the torque goes up, and now the motor speed goes down, and the velocity limit has not been reached. But if I remove that load, as before, look at that 1700 comes back up, the velocity limit has been reached. And the final solution checkpoint was to observe pot and knot don't stop the motor. I can see I don't even have pot and knot connected, but if I were to hit them, I just turned on both pot and knot, not something that would normally happen in an application, but they are high and unaffected by motor speed. So pot and knot, although the pins can still be monitored, pot and knot are not being used. So back here to my original application, I initialize the parameters, I use the setup wizard. Let me label the terminals. The analog command comes in torque mode pins 9 and 10. Now how do I know that? It says right here in wiring check that torque is CN1 pins 9 and 10. The wiring check also shows me that servo on is pin 40 of the same connector, the I/O connector CN1. So for my wiring diagram I could put in a 40 to remind myself there. This was the V comp signal on pins 29 and 30. And then what about encoder feedback? I can see that the phase A, PAO, phase B output, and phase C for the encoder feedback to the controller are pins 33, 34, 35, 36, 19, and 20. 33, 34, sorry about my penmanship here, 35, 36, 19, and 20. What parameters were changed? We can look at the parameters that were changed in the software by pulling up the Edit Parameters screen again and looking at the Differ from Constant tab. I can see all of the parameters that have been affected, and it's not all that many, but it's a good idea to look here and see if there's any parameter you don't expect to see changed. Now, often tuning is important to your application, but since we're in torque mode, not a lot of tuning really applies. In this case, perhaps just a torque reference filter. That's outside the scope of this video. So there we have it, a torque mode application example.